Hello everyone, welcome to today's class. This is teacher Simon taking you through Cambridge International AS and A-Level Mathematics, paper 4-1 May June 2024, and this is part 2 for questions 5 to 7. Question 5, a straight slope of length 60 meters is inclined at an angle of 12 degrees to the horizontal. A bobsled starts at the top of the slope with a speed of 5 meters per second. The bobsled slides directly down the slope. Part A, it is given that there is no resistance to the bobsled's motion. Find its speed when it reaches the bottom of the slope. There are two methods I can use here. Number one, the energy method. So this is the bobsled. Of course, here is mg cos the vertical component of the weight, mg cos 12. If this one is 12 here, the angle of rotation 12. Remember, we have the mg which is here. The same angle here, 12. Then here we shall have mg sine theta, that's sine 12. Okay. When we resolve this mg, you close in, then it is cosine, you open up, it is sine. Then we have this one as 60 meters. Okay, 60 meters. Then automatically here we shall have the normal reaction. Now, using the energy method, so when this particle comes down here, it is going to have the final speed, which we don't know. So therefore it has kinetic energy. But then up here, since we have, let me try to shorten this one. Okay, the mg, and then let me make this one to be my h. So the h here, we need to find it. Then here there is kinetic energy because it starts with a certain speed, u, which is equal to 5 meters per second. And then there is also potential energy because there is vertical height generated here. Now using SOHCAHTOA, this is the right angle triangle. So sine of 12 is equal to h. That is the opposite over the hypotenuse, which is 60. Then that means we can cross multiply and our h becomes 60 sine of 12 degrees. You see? Now, we are going to use work done. Let me just shorten it. Work done by the driving force minus work done against resistance is equal to the change in mechanical energy. Okay. Now, since this one is just sliding down on its own, then there is no driving force. Okay. Because they said a bobsled starts at the top of the slope with a speed of that 5 meters per second. The bobsled slides directly down the slope, so we don't have the force that is applied to take it down. It is not this mg sine 12 when you are using this energy method. You can use the mg sine 12 in that method of F is equal to ma when you are using also the equations of motion. Okay, so this one is not going to be used here. So that means the work done against, by the driving force is 0. Then since this is it a smooth plane? So they never said whether the slope was smooth or rough. So we take it as smooth, therefore there is no resistance force, 0. Then change in mechanical energy. So the final is this one here. Then I will say a half m. Because remember, mechanical energy is equal to gravitational potential energy, then plus kinetic energy. This one is mgh, this one is a half mv squared. So the mass, do we know the mass? The mass, we don't know it even. So we just put m, then v squared, then minus. Now the initial, we are having kinetic energy, which is a half m, and then the velocity here is 5 squared, then plus gravitational potential energy is mgh, so mg, and then h is 60 sine of 12. Now I can take this one, this side, okay, and then we have a half m, half 25 m, okay, then is going to be equal to plus our 600 of m, then sine of 12, okay, then is equal to a half mv squared. Now m can disappear, okay, everywhere, and now we can multiply all through by 2. If I multiply all through by 2, I will be eliminating the 2 in the denominator. So this one will be 25, then plus this will be 1200, then sine of 12, which is equal to v squared. So meaning our v is going to be equal to the square root of 25 plus 1200 sine of 12. So putting this in the calculator, we get square root of 25 plus 1200 sine of 12. This one gives us 16.6 to 3 significant figures. So v is equal to 16.6 meters per second. Now, another method you could use here, okay, the one of the forces, alternatively, you could say that using F is equal to MA. Remember, I put also these forces here. So there is mg sine, this one going down, okay. It's the only force, so there is no opposing force this way, okay. So then that one minus 0 then is equal to ma. So we are going to put mg sine of 12 then is equal to ma. Automatically m will go, then we shall have 10 sine of 12, which is equal to the acceleration, okay. Now after getting the acceleration, I can use the v squared is equal to u squared plus 2as. So that means my v is going to be equal to the square root, e is 5, so I will square it, then plus 2 times the a is 10, then sine of 12, then times the distance traveled is 60. Okay, do you see that this is 20 times 60, which gives you the 1200? So it's the same thing that we have before. So that means the velocity is going to be 16.6 meters per second. As simple as that. Part B, it is given instead that the coefficient of friction between the bobsled and the slope is 0.03. Find the time that it takes for the bobsled to reach the bottom of the slope. Now this means that there is frictional force. So now the plane is rough. So I have my particle here, there is r here, then there is mg cosine here. Okay, mg cosine of the 12, and then remember this is 12 here, there is mg sine. This is mg sine 12, and this is 60 meters here. Then after that, there is now this mu r here. Okay, there's that mu r there. So mu is given, the coefficient of friction is given as 0.03. Now, since there is no vertical motion, that means the r, the normal reaction, is equal to mg cos of 12. Now, using F, which is equal to ma, I can have this one going this side, okay, 10 m, okay, because g is 10, okay, so 10 m, then sine of 12 minus mu r. So mu r is 0.03, r is 10 m, then cosine of 12. You see that? Then it's equal to ma. You can divide through by m. You can see it can disappear everywhere. So that means we shall have 10 sine of 12, then minus 0.03 times 10, that will be 0.3, then cosine of 12, that would be our acceleration. Okay, I can keep it there. Then I can use an equation of motion that gives me time. So it can be s is equal to ut, then plus a half at squared. So the s is 60. Initial speed was given as 5, then plus a half times the acceleration we have gotten as 10 sine of 12 minus 0.3 cos of 12, and then the time t squared. Now I'm supposed to solve this quadratic equation, so times 2 everywhere such that I can eliminate their half with the denominator. Then we are going to have we can have here 120, then which is equal to 10 here. Remember, we are multiplying all through by 2, then 10 sine 12, okay, minus 0.3 cos of 12. This is the coefficient of t squared, which is equal to 0. In other words, let me rearrange it. I can have 10 sine of 12 minus 0.3 cos of 12, then t squared. This one is plus 10t. Okay, then when this one of course comes this side, it is a minus, so we shall have minus 120, which is equal to 0. So this is a quadratic equation in t. Now I can solve it maybe using the quadratic formula. So t is equal to minus b, that's minus 10, plus or minus to the root of 10 squared minus 4. Our a is the 10 sine 12 minus 0.3 cos of 12 for a, then c is negative 120. Then out of 2a, and the a is again 10 sine of 12 degrees minus 0.3 cosine of 12 degrees. So of course, this whole thing, we are not going to take time as negative, okay? We are going to take time as positive. So I'm not going to consider the minus here, okay? So putting everything in the calculator, we are going to have a negative 10, then plus square root of 100, then 4 times 120, that one is 480. So I can say plus 480, because the negative times the negative, you get a positive. And then here we have 10 sine of 12, okay, minus 0.3 cos of 12. Then I'll close that bracket. Then I come down here and I say 2 into, this is 10 sine of 12, then minus 0.3 cosine of 12, and close the brackets. So we have 5.86 to 3 significant figures. Seconds. So 3 significant figures. Then we close that. Question 6. A particle moves in a straight line starting from a point O. The velocity of the particle at time t seconds after leaving O is v meters per second. It is given that v is equal to k t to the power of a half minus 2t minus 8. Now this is variable acceleration, where we are given the expressions for either acceleration, velocity, displacement, And we don't use the three equations of motion. The v is equal to u plus at, s is equal to ut plus a half at squared, and v squared is equal to u squared plus 2as. We only use differentiation and integration, okay? So they are saying here where k is a positive constant, the maximum velocity of the particle is 4.5, so that k is equal to 10. Now for maximum velocity, that means you cannot accelerate any further, okay? So the rate of change of velocity with respect, or the rate of change of velocity is equal to 0, which is your acceleration, okay? Now we are going to differentiate. What is dv dt? Drop the power, okay, then reduce it by 1, so you get here negative a half, then minus 2 here. This one you equate to 0. So we shall have k over 2 square root of t is equal to 2. You see that? Then we can square, cross multiply, you have k, which is equal to 4 root of t, okay? And then that means that our t, if I square both sides, okay, square both sides, this therefore implies that t is going to be k squared then over 16. So let me keep this one. Then they say that v is equal to 4.5. v is equal to 4.5. The maximum velocity of the particle is 4.5. So now I can substitute. This is the value of t. So if I'm to find the maximum velocity, I get that value of t. I put it in the expression for v, and the expression for v is k, then t to the power of a half, minus 2t, then minus 8. So I'll put here 4.5, which is equal to k, and then the square root from here, the square root of t is equal to k over 4, okay? So that's why we have t is equal to k squared over 16. So here we have k over 4, then minus 2t. The t is now k squared over 16, then minus 8. You see? Now you can simplify this. Bring 8 this side. 8 plus 4.5, you get 12.5. Then here we have k squared over 4, then minus, this will be k squared over 8, okay? So we can multiply all through by 8. So 12.5 times 8, it gives us 100. So here we shall have 100. Then when you multiply here by 8, you will get a 2. Okay, 2k squared. Then here, of course, k squared. So meaning k squared is equal to 100. And then when you take the square roots on both sides, our k becomes the 10. And remember, they said it is a positive constant. Okay, so we don't put plus or minus for this case. Part B, Roman 1, verify that v is equal to 0 when t is equal to 1 and t is equal to 16. Now, for t is equal to 1, what is the expression for velocity? The expression for velocity is k, which k is 10, then t power half, minus 2t, minus 8. Now, what is our velocity? 10, then we put 1, of course that will be 10 here, then minus 2 times 1, minus 8. This one gives us 0, 10 minus 10. And then for t is equal to 16, v will be equal to 10 into the square root of 16. That one will give us a 4, then times 10, that is 40, minus 2 times 16, that is 32, minus 8. So if you get minus 32 minus 8, that is minus 40, and then a 40 here, that means this one goes to the 0, as simple as that. Now, Roman, to find the distance traveled by the particle in the first 16 seconds. So before you find the distance traveled by the particle, always get the times when the speed is 0. Because we can have something like this when the curve now goes beyond the t-axis, maybe it comes back like that. That means this area here below the t-axis is now going to be a negative when you are integrating. So when you integrate right from here, then up to maybe this other time this way, it is going to be wrong, because there is the negative part which is going to subtract itself off from these positive ones. So you have to find the times when the speed is 0. So you look at this one individually, then this one, but then you put the modular signs to make it positive, and then this one. So distance is a scalar quantity. It cannot be a negative, okay? So you need to put that in the mind. Now, distance traveled is going to be the integral of velocity. Then distance is the magnitude of the displacement. So here we shall integrate from 0 to 1, because they said that the velocity is 0 when t is equal to 1. So we shall say from 0 to 1, okay? And then 1 to 6. So the expression for velocity is 10 t power half. We integrate here because velocity is the rate of change of displacement. That means if you need s from here, then it is going to be the integral of v dt. Okay, so this is 10 t power half, then minus 2t minus 8 dt. Then we don't know whether this one is below the t-axis. Just put the what? The modular signs. Then integrate from 1 now to 16. Also the same 10t power half minus 2t minus 8 with respect to t. You also put this one in the modular signs. You don't know which one is negative, okay? Now when we integrate, you increase the power by 1, you divide by the new power. So we shall get, this is t power 3 over 2, then over 3 over 2. And here you have 10. Then this one will somersault, it will come up. So 10 times 2, that is 20, then 20 over 3. That is what we are going to have here, 20 over 3, then t power 3 over 2, then minus, this will be t squared, then minus 8t. And then we shall have 1, 0. So the same thing we shall have here, the modulus of 20 over 3, then t power 3 over 2 minus t squared, then minus 8t. Okay, then this is from 1 to 16. Then we can put 1, of course this will be 20 over 3 minus 1 minus 8, then minus, because when you put 0 it will be 0, then plus, put 16, so we shall have 20 over 3, then 16 here, power 3 over 2, minus 16 here, squared, then minus 8 times the 16, okay? Then after we subtract, when you put 1, it is 20 over 3 minus 1 minus 8, like that. Now 20 over 3 minus 9, because minus 8 minus 1, that is minus 9, so minus 9, this one gives us negative 7 over 3. So you see that here we have a negative, so but when we put it in modulus, it is going to give us a positive value. 20 over 3 20 over 3, then times 16 power 1.5, then minus 16 squared minus 8 into 16. This one gives us 128 over 3, 128 over 3, then minus, of course the other one is negative 7 over 3, okay? So this one now will give us 7 over 3 out of the modulus. Then 28 plus 7, this one here plus 7 over 3 will give us 45. So plus 45. Then 45 times 3, that one gives us 135. Then 135 plus 7, that is 142. So our answer here becomes 142 over 3 meters. If you want, you can put it to 3 as significant figures. 142 over 3, which is 47.3. Question 7. A particle P of mass 0.2 kilograms is projected vertically upwards from the horizontal ground with speed 25 meters per second. Part A show that the speed of P when it reaches 20 meters above the ground is 15 meters per second. Now in my sketch here, I'm going to have this one projected vertically upwards, but then it will reach maximum height and then it comes back. Okay, so it is projected from here with a speed of 25 meters per second. Then there is going to be that height here when it is 20 meters. Okay, so they are saying show that the speed of P when it reaches a height of 20 meters above the ground is 15. Now, of course, we can use V squared is equal to U squared plus 2AS. So it's very easy. Our V is going to be the square root of U, which is 25 squared, then plus 2. Our S, since it is a vertical projection upwards, it is going to be negative 10. That is the acceleration. And then the distance traveled is 20. So we shall have here 625. Then 20 times 20, that is 400. And then you get the square root here of 225, which is actually 15 meters per second. Okay, just like that. There is also another method. We can use the energy method too. So when it reaches here, we are having kinetic energy because there is a certain speed. There is also potential energy here, you see. And then here we are having only kinetic energy because there's that projection there. And you know that we can use the work energy principle is work done by the driving force minus work done against resistance, then is equal to change in mechanical energy. So work done by the driving force, since it is just projected and it is moving on its own, the work done against, by the driving force is 0. Then there is also no resistance to the motion. Then this way we have final mechanical energy is the sum of kinetic and potential energy. Now, so final we are having potential energy, which is 0.2. Remember, potential energy is mgh. Okay, kinetic energy is a half mv squared. So we shall have 0.2 times 10, then the h is 20. You see that? Then plus the kinetic energy is a half, m is 0.2, and then the speed, we don't know it. But then we subtract, this is the final, and then the initial, we're having kinetic energy, which is a half times the m, which is 0.2, then times the 25 squared. So I can bring this one this side to become a positive. Okay, so we shall have 25 squared is 625, then times 0.1, this one can be 62.5, which is equal to this is 200 times 0.2, that one will give us 40. Okay, so I will even bring it this side and I say minus the 40, then it's equal to a half of 0.1 of 0.2, that is 0.1 v squared. So meaning v is going to be the square root of 62.5 minus 40, that will be 22.5. Then when you divide by 0.1, you get 225, and then the square root of that is going to give us 15 meters per second. You see? Then they're saying when P reaches 20 meters above the ground, it collides with a second particle q, okay, of mass 0.1 meters, kilograms, which is moving downwards at 20 meters per second. P is brought to instantaneous rest in the collision. And then they say part B, find the velocity of Q immediately after collision. So let's say Q is coming from up there, then it collides with P. P was moving from down here. So P had moved a distance of 20 meters, then they collide. This is your P, this is your Q, okay? Now, using the principle of conservation of momentum, where momentum before collision is equal to momentum after collision, then the mass of P, the initial velocity of P, then the mass of Q, initial velocity of Q, then is equal to the final mass of P, then Vp, then plus MQ, VQ. So here we can have 0.2 times 15, then plus 0.1. Since it was moving in the opposite direction to that of P, then it will be a negative here. So we put negative 20, which is equivalent to, now they say that P is brought to instantaneous rest. That means its momentum is 0 here after collision, and then the mass of Q is 0.1. Then we are looking for its velocity. 0.2 times 15, this one gives us a 3, then this one will give us a 2. Then we shall divide by 0.1 to get VQ. Now, VQ here, 3 minus 2 is 1. Divide by 0.1, you get 10 meters per second. So the speed of Q after collision is this. Now, you can check that we have used the negative 20 here. Remember, velocity is a scalar, is a vector quantity. So the magnitude and direction matter. Now, since the value we have gotten here is positive, this means that Q is now moving upwards. Q now moves upwards with a speed of 10 meters per second, okay? Because it is positive, this one is negative, now this one is positive, so that is an opposite direction movement. When P reaches the ground, it rebounds back directly upwards with half of the speed that it had immediately before hitting the ground. And then they are saying part C, find the height above the ground at which P and Q next collide. Now, we need to first find the velocity of P before hitting the ground, or the velocity with which it hits the ground before reaching the ground. So we can use V squared is equal to U squared plus 2AS. Now V is going to be equal to the square root. Now the initial speed of P here is 0 because it was brought to instantaneous rest, okay? So 0 squared, then plus 2. The acceleration is 10 because P is moving downwards, okay? Then times, the distance is 20 because they collided at 20 meters above the ground. This is 400, so root of 400, that is 20 meters per second. Now, time taken to reach the ground, we also need to know it. Time taken to reach the ground. So time taken to reach the ground, we can use maybe V is equal to U plus 80. Already we have, if we make T the subject, it is going to be V, which is 20, minus U, which is 0 over the acceleration, 10. So those are 2 seconds. Now, SP. Now, this one moving now upwards. Okay, we need to find SP. SP is equal to UT plus a half AT squared. So here we shall have when it moves up after hitting the ground, they said that it rebounds back directly upwards with half of the speed that it had immediately before hitting the ground. So with a half of this one here. So we shall have a half of that 20. You see that? Then it takes some time as it is moving up. So we don't know what time that is. And as it goes up, this is negative 10, the acceleration, then t squared. So meaning SP here is going to be 10t minus 5t squared. So I can keep this expression. And then how about Q? Now, also SQ is going to be equal to UT plus a half AT squared. But the U for Q, we found it here after collision. V moves with 10, okay? V moves with the speed of 10, so we shall have 10 here, 10t, but what is the time here? T is going to spend, Q is going to spend t plus 2, okay? T plus 2 seconds. Why? It's because, remember, when they collided here, Q moved up, okay? And then P went down. It came to instantaneous rest, then it came down. When it came down, it spent 2 seconds. As it was spending 2 seconds to move down, Q was also moving in those 2 seconds altogether. Then next, P moves up. Now we are finding the SP. Even Q is also moving, so we don't know whether it is coming back, so we want the S of Q. So the time spent by Q in motion is going to be the 2 seconds that P has taken here when it is moving down, even Q is moving up. Now, we are now looking at from the ground here as P is going up, as it takes T seconds to move up, Q is in motion for that T, then plus the 2. You see that? All right. Then we are going to have now T plus 2, then plus a half, then negative 10. Me, I'm considering as if Q is still moving upwards, okay? Still moving upwards, so the acceleration due to gravity is negative 10, because remember after collision Q moved upwards, and then here we shall have t plus 2 squared. Then we can simplify this. This will be 10t plus 20, then minus, this will be 5. Inside here we shall have t squared plus 4t, then plus 4. So when we open, this will be 10t plus 20 minus 5t squared minus 20t minus 20. All simplified to something cancels here, this 20 and this one. So we get minus 5t squared. Then 10t minus 20t, we get minus 10t. That is our SQ. Okay. Now, when these two collide, they are the same distance from the ground. Okay. Let me write here. On collision, P and Q are the same distance from the ground. Now, that means since after the first collision, Q was moving up, the distance traveled by Q in total, SQ, let me just put SQ total, okay, it is going to be this negative 5t squared we have gotten minus the 10t. Then we shall add on the 20. Remember when they collided at first, when they collided here at first, it was at 20 here. Do you see this? Then Q moved up. Huh? So we are having the SQ here as it is moving up. But of course it moved up and maybe came down and then met with P again when they collided. So we are taking the SQ here and then the 20, okay? So the SQ up there plus the 20. So that's why I'm taking the SQ total here. That is the one. Now we can equate them. So we can have 10t minus 5t squared, that is SP. So SP is equal to SQ total. So we equate to minus 5t squared minus 10t plus 20. Of course, this one will automatically cancel. Bring the 10 this side, it becomes 20t, which is equal to 20. Dividing all through by 20, t becomes 1. So they collide again after 1 second when t hits the ground, okay? Now, using SP, which is equal to 10t minus 5t squared, we can just substitute here. 10 times 1 minus 5 times 1 squared. This one will give us 5, okay, meters. So this will be our answer. So that means these two, they collide again at 5 meters above the ground. 5 meters above the ground. So this has been it for this part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly give us the thumbs up, share, and even subscribe. See you in the next videos.